Hello everyone. So today we're going to look at section 7.2, which talks about right triangle trigonometry. So if you recall, a right triangle has two legs and we have an hypotenuse. The hypotenuse is usually opposite from your right angle, and then the side that is opposite, we refer to that with, so let's say we make an angle. In this case, our angle is T. The side that is directly in front of T is your opposite side, and the side that is right beside your angle T is what we call your adjacent side. Now, we can use this triangle to come up with what we call trigonometric ratios. The first three that we're going to look at are sine, which we shorten and just say sin. So we're going to look at sine of t. We're going to look at cosine, which we shorten as cos. And we're going to look at tan, tangent actually, which we shorten as tan. So the ratio for sine of t. So sine of t is going to be your opposite side, just say OPP for opposite, over your hypotenuse. You may hear sometimes the phrase so. So this is something we use to remind ourselves. So this is sine is opposite over hypotenuse. Cosine of t, the ratio is going to be your adjacent side over your hypotenuse. We have a abbreviation of ca for this one. And then tangent of t is going to be your opposite side over your adjacent. And so tan is toa. And so you may have heard, some of you maybe, the term SOHCAHTOA. We usually use SOHCAHTOA to help us remember these ratios, which means that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now, let's say we were to inscribe a right triangle in a circle with radius 1. We can find the trigonometric ratio using this exact triangle. So you can apply the trigonometric ratio to any triangle. So in this instance, let's say we wanted to find sine of t. So here's my angle t. Notice that my height of my triangle, or in this case, the opposite side, has a length of y, and the adjacent side has a length of x. My hypotenuse is going to be my radius, which is 1. So sine of theta, recall that sine is opposite over hypotenuse. If we were to fill in, the opposite would be y, hypotenuse would be 1. So in other words, sine of t is my y coordinate. Similarly, if we have cosine of t, recall that's going to be adjacent over hypotenuse for a ratio, which in this case, our adjacent side is going to be x. My hypotenuse is 1, so this is going to be equal to x. And then tan of t is going to be equal to opposite over adjacent, which is equal to y over x. And if you notice, this is really sine over cosine, because sine is y, and cosine is x. But we'll look at this further as time progresses. Let's do some practice. Let's say we have a right triangle. Our angle in question is alpha, and we're told to find cosine of alpha. So we have the sides here, so we can just plug in. But we have to recall what my ratio is, right? So cosine of alpha has a ratio of adjacent over hypotenuse, right? And so what is my adjacent side? Again, my adjacent side is going to be the side that is right beside my angle. In this case, it's 15. And my hypotenuse is 17. So cosine of alpha is 15 over 17. And usually when we're doing these type of problems, you will keep your answers in fraction form. You will not give a numeric value. Let's try another example. Let's say here we want to find sine of t. So recall, sine is opposite over adjacent. I'm sorry, over hypotenuse. So my opposite side from t is 7, and my hypotenuse is 25. So that's my answer. Now, those were the first 3 trig functions. They're very common. Usually those are what we're usually using. However, we also have 3 other reciprocal functions. And so these are secant, cosecant, and cotangent. So the ratio for secant of t is hypotenuse over adjacent. And the ratio for cosecant of t, we're still using this. You can really ignore the values for the sides. But the ratio for cosecant of t is hypotenuse over opposite. And the ratio for cotangent of t is adjacent over opposite. So just to kind of let us understand opposite and adjacent, because there's some people who kind of have a little hard time of figuring out what is adjacent, what is opposite. So basically, again, your hypotenuse is fixed, right? So your hypotenuse is going to be the side that is directly across from your 90-degree angle, regardless of how the triangle is drawn. Your adjacent side, it depends on where your angle is, right? So after you have your right angle or you establish your right angle, then there are 2 additional angles in the triangle. Depending on which angle, you have corresponding opposite sides and adjacent sides. The opposite side are going to be the sides that are, or the side that is facing the angle. So for instance, this side here is opposite from B. So we say that, oh, this is opposite for B. But it is adjacent to this side. So the side here is adjacent to B. Likewise, this side is opposite from alpha. So this side is opposite alpha, but it's adjacent to alpha. This one is adjacent here. So it's once you're able to correctly establish these, you can plug them into your trigonometric ratios. Now we're going to find trigonometric functions of special angles using side angle length. Okay, so for instance, let's say I draw a a triangle again, inscribed in the circle. And again, we're going to let the radius be 1. So this is going to be 1. And this, let me draw it a little bit better. No, that's fine. This is going to be 60 degrees. And recall that 60 degrees is equal to, well, if we wanted to change it to radians, because that's what we're going to really be looking at, we do pi over 180, right? This is going to be pi over 3. So really, this is pi over 3 degrees. Okay, this is my right angle. So now if this is 90, this is 60, then that means this must be 30 degrees. And so 30 degrees times pi over 180 will give me the radians here. So this is pi over 6. Okay, so these are my angles. Okay, now there are some special, so this is what we call a 30, 60, 90 degree angle triangle, and this is a very famous triangle. And with this triangle, there is a relationship with the sides. So basically, if the base is S, and that's going to be the side opposite to your 30 degree, then your hypotenuse is going to be 2S, and your leg, or your opposite, is going to be the square root of 3S. So this is just something to keep in mind. It's just a special type of triangle. The right triangle always has this relationship with the sides. Another special, so we call this a 30, 60, 90 degree triangle. Another type of special triangle is the 45, 45, 90 degree triangle. So again, I'm going to have my my right triangle inscribed in my circle. And so we can also figure out what is 45 degrees in radians. So that's going to be pi over 4. So both of these angles are going to be pi over 4. So if both of these are pi over 4, then my sides are going to be the same. SS. Oops. And then my hypotenuse, the relationship here, is going to be the square root of 2 times S. So for any right triangle that is a 45, 45 degree, 90, 45, 45, 90 degree triangle, this relationship holds for the sides. Let's look at a quick example. It says, find the exact value of the trigonometric functions of pi over 3 using side lengths. So basically, we want to use pi over 3. So what I'm going to do is just pull this to our example. Oh, it didn't work so well. Maybe not. Okay, never mind. I'll just redraw the triangle. So this is going to be pi over 6. No, pi over 3. Pi over 6, right? And so then my sides will have a relationship of S root 3 of S times S rather, and 2S. So now let's use this to find our other trigonometric, functions of pi over 3. So this is my angle in question. So that means my opposite side is going to be root 3 over s. Root 3s. And then my adjacent side is going to be s. So if I were to look for sine of pi over 3, remember that's opposite over hypotenuse. So that's going to be equal to root 3s over my hypotenuse, which is 2s. And the s's will cancel, so this is just going to be root 3 over 2. Cosine of pi over 3, that's going to be adjacent over hypotenuse. And so my adjacent side is s over 2s, cancels, and that's going to give me 1/2. Then I'm going to look at tan of pi over 3, which is opposite over adjacent, which is going to be equal to root 3s over s. S is canceled, so I'll get root 3. We also want to find secant of pi over 3. Well, we know this is going to have a ratio of hypotenuse over opposite of, adjacent. So that's going to be 2s over s, which gives me 2. Then I have cosecant of pi over 3. That's going to be equal to hypotenuse over opposite, which is 2s over root 3s. The s's cancel, but note that we don't normally keep a root in our denominator. So this is root, we can rationalize this, multiplying by the root. So this becomes 2 root 3 over 3. And then the last one, cotangent of pi over 3 equals, this is an equal sign, s over, equals adjacent over opposite, which is s divided by root 3s. Of course, they cancel. We multiply by root 3 over 3. And so this becomes root 3 over 3. And that's how you would use your special triangle to find your trigonometric ratios. Okay, now we're going to look at using equal cofunction of complements. Alrighty, so we previously discussed this 30, 60, 90-degree triangle. If we look at what we just found, what do you notice? So if you look here, notice that sine well, maybe we should find also. Let's look at sine of pi over 6. So we just found that, of pi over 3 rather. So sine of pi over 3 is opposite over hypotenuse. So that's going to be root 3 over 2. But I want us to look at cosine of pi over 6 and see what we get. So cosine of pi over 6 is adjacent. My adjacent of cosine is this side here, which is root 3s, and my hypotenuse is 2s. What do you notice? They're the same. If we were to look at, let's say, sine of pi over 6, so that's opposite, which is s, over hypotenuse, that's 1/2. But look at cosine of pi over 3. That's going to be adjacent, which is s. Adjacent of cosine is here. Adjacent of pi over 3 is there. And your hypotenuse is 2s. This is also 1/2. So this is what we call cofunction of complements. So in essence, sine of alpha, if you have a triangle in this form, or a right triangle, then sine of alpha is going to be equal to cosine of beta, and sine of beta is going to be equal to cosine of alpha. We actually can use this to come up with a set of identities. These identities are called cofunction identities. So let's say we have our 90-degree here, and we have an angle, let's say this is t. Okay, so if we want to put it in the cofunction identity form, we know that 90 degrees is going to be equal to, let's put it in radians. And eventually you should be able to come up with this off the top of your head. Be sure to study the unit circle, guys. Or, well, yeah, we haven't really covered it, but previously we looked at the different common angles and their corresponding radians. Definitely want to keep that in mind. So this is going to be pi over 2. Okay, so if this is 90, we know that these two angles must add up to also 90 degrees because the total sum of a triangle is 180 degrees. So if I wanted to find this angle in terms of what we have here, so this is pi over 2. So then if I wanted to figure out what this angle is, then it's going to be 90 minus t, because we know that these two angles, so since this is 90, we know that these two angles must sum up to 90. And we just stated that 90 degrees is pi over 2, so this angle is going to be pi over 2 minus t, or you can say 90 minus t is going to give us that angle. So how does this come into play? Well, recall that we just said that if you have a triangle in this form, a right triangle, then sine of alpha is cosine of beta, the opposite side, the opposite angles. Well, sine of t is going to be cosine of pi over 2 minus t, which is seen here. Cosine of t is going to be equal to sine of pi over 2t. And we also have another, the two sets of cofunction identities. Secant of t is equal to cosecant of pi over 2 minus t. Cosecant of t is equal to secant of pi over 2 minus t. Also, tan of t is going to be equal to cotan of pi over 2 minus t. And cotan of t is going to be equal to tan of pi over 2 minus t. These are going to come in handy when we try to do trigonometric equations and so on. So definitely keep them in mind. So let's do some examples. So if sine of t is 5 over 12, can we find cosine of pi over 2 minus t? Well, these two functions are cofunctions. So that means that sine of t must be equal to cosine of pi over 2 minus t. So with that said, if sine of t is 5 over 12, then cosine of pi over t must also be pi over 12, 5 over 12 rather. So that tells us that cosine of pi over 2 minus t is 5 over 12. Alrighty, so let's say we're given a triangle and we need to figure out the missing sides. And this is quite a popular type of problems. Usually, what we would first note is our trigonometric ratios. So here they give us an angle. So what is missing is one of the legs, which in this case would be your adjacent side, and your hypotenuse. So if you're trying to find a missing side, you would think of which ratio involves that side. And you wouldn't use a ratio that involves the two unknowns. For instance, you wouldn't use adjacent over hypotenuse, because then you would have two unknown sides that you can't use to help you find the information. So if we're looking at our angle here, 30, and you can almost always just put what this is, because you can also use this angle as well, because we know that this would be a 30, 60, 90 degree angle triangle. So since I have the opposite side, let me try to find A first. Since I have the opposite side and A is adjacent, I'm going to look for the trig ratio that has opposite and adjacent, and that's tan. So I'm going to say, well, tan of 30 degrees is equal to opposite over adjacent. In this instance, my opposite side is 7 and my adjacent side is A. So basically, tan of 30 degrees is 7 divided by A. So if I wanted to find A, well, we can first cross multiply. And then divide both sides by tan of 30. So you can actually plug this in your calculator to get a value. So this means that A would be equal to 12.1. So there should be a tan function on your calculator, and you can just plug it directly in. So we found A, very good. Now we need to find C. Now we have A, you can actually use any trig ratio you desire, because you have two sides and one is missing. So let's say we want to do, we can do sine using the same opposite side. So sine of 30 is going to be opposite over hypotenuse, which is going to be 7 divided by C. And so you can do the same thing. Multiply both sides by C, and then divide both sides by sine of 30 to get C by itself. So this gives us that C, plugging this in your calculator, you should get C equals 14. You could also remember or recall that if we had that, since it's a special triangle, If this is S, then your hypotenuse is going to be 2S. So C would be 2 times 7, which is 14. And your other side is going to be the square root of 3 times 7, which is S in this case. But it's always good to practice. Now we're going to look at using right triangles to solve trigonometric applied problems. So these are very common in pre-calculus, also calculus. So basically, a right triangle trigonometry has many practical applications. The most common is you may hear, for example, the ability to compute the length of a side of a triangle that makes it possible to find the height of a tall object that is overcast in a shadow of some sort, or something like that. So in this instance, this would be looking like a light pole or something. And the shadow here, you'll say, oh, it casts a shadow to the ground with an angle of elevation. Here is your angle of elevation. Sometimes you'll hear about your angle of depression. And so this, would be a right angle. So sometimes you get questions like this, and it always helps when you get these type of questions to draw out what you are hearing or reading, so you can have an idea of what you're being asked to solve for. So for instance, here we want to find the height of a tree. A person walks to a point 30 feet from the base of the tree. So if we draw a tree, you'll just have your line to say, oh, she walked 30 feet. She measures an angle of 57 degrees between a line of straight to the top of the tree and the ground as shown. Find the height of the tree. So if you were to look at this as a right triangle, this is my right angle, right? I have a angle and a side. In this case, the adjacent side. So I want to find the height of the tree, x. So in this instance, what do I need to do? Well, this means I need to figure out which trigonometric ratio involves adjacent, and this x, the height of the tree, is opposite, and that's going to be tan. So we know that tan of 57 is going to be my adjacent, my opposite rather, over adjacent. So in this case, my opposite is the one that's missing, and my adjacent is 30. So here we have that tan of 57 degrees equals x over 30. So we can just multiply both sides by 30 to get x. What we get here, once we plug it in our calculator, is that x is going to be 46.2. That's going to be my height. Let's say h, since it's talking about height. It doesn't matter your variable. So that's going to be the height of the tree. If they asked us for the shadow cast by the tree, then that would be your hypotenuse. Okay. Okay, we'll stop here for today. Be sure to be on the lookout for your homework and make sure you do it in a timely manner. Have a good one, guys.